Good morning, everyone, and thanks for joining the session. Ramsey, you can maybe turn on the camera so I can get a view of people also. So in today's session,
Sir? This? No.
So in today's session, what we'll do is learn something which can be used by students to create diagrams on their own in the classroom setting. So typically, we'll focus on a kit which is referred to as a geom kit. It's a part of a bigger kit. We refer that kit as mathematics kit. So let me first give you an overview of what is mathematics kit. So mathematics kit is a combination of two things. One, a set of tactile diagrams. When I say tactile diagrams, basically these are embossed representations which a child with visual impairment can touch and see. It's a big collection of tactile diagrams which cover concepts of geometry from class 1 to class 10. So it is developed in two volumes, volume A and volume B. Volume A is for students of class 1 to 6 and volume B is for class 7 to 10. So the idea is this covers all the concepts which are taught to students in these classes. So once the teacher and the student has the access to this tactile book, then the problem of having access to a diagram is completely solved. This comes in a big ring binder. Ring binder is there, and in that you have all the books, etc. So we'll do a separate session for this once you have books in your hand. And this particular tactile book we call the complete name is Tactile Encyclopedia for Geometry. So this is developed in collaboration with Xavier Resource Center for the Visually Challenged in Mumbai. And we'll cover this in detail in a separate session. In today's session, we'll cover the second part of this mathematics kit, which is the set of instruments or the tools that can be used by a child to actually create tactile diagrams. You understand the importance, because see, as a teacher, if you give a child tactile diagram, that is fine. So level one problem is solved. Now children have access to tactile diagrams. But what about level 2 problem? Once they know the concept, but if they are not enabled to create diagrams on their own, then the problem is not solved. So for that part, this geom kit comes into picture and plays its role. And geom kit serves two purposes. One, it is a set of tools for the children to create diagrams on their own. Plus, it's an important kit for teachers. By using these instruments in the kit, you can actually create diagrams for your children, not only for mathematics, but in fact for any other thing. So if you're teaching any concept in the class and you want to create a tactile diagram on a braille paper, then you can use this geom kit also. That's the broader use of the geom kit. Till now, any doubts? If you have, you can ask me about this combination of kits. Any doubts or questions, or should I move forward?
You can move forward.
Okay. Now, little bit on the background of this project. So this is a project supported by and Raise Lines Foundation. At Raise Lines Foundation, we manufacture all these kits. This particular Geom kit is developed by a person. His name is Mr. Anupam Garg. So he spent a lot of time in trying out this kit with various students, and then we have manufactured it at Raise Lines Foundation. And this overall project is supported by NIIFL as part of their CSR initiatives, through which we are able to send you these kits free of cost. So now let's actually start and learn how to use this kit. So once the kit is in front of you, you can just open it. You can try with me, so we can do it together. So when you can open it, the side from which it is open, normally we put masking tape or the paper tape. So it's easier for the child to recognize the difference in texture and identify the side from which the box would be opened. So you remove these paper tapes to open the box. Once the box is opened, the next thing is the set of tools which are there in the kit. So things are explained step by step. So first we give the overview of each component in the kit. And once children are familiar with the position, orientation, and the brief function of each component, then we move on to the detailed use. So let's first understand. Once you open the kit and you move your hand to the left side, this orientation is also important. Move your hand to the left side of the kit, then start going towards right side. The first component or the instrument that you identify is a long instrument, which has tactile markings on it. So it is a combination of embossed lines and dots, and it's like a scale. The one edge of the scale is plain and the other edge has teeth. One edge is completely plain and the other edge has teeth. So this is my tactile scale. I will be using this for making, for doing measurements, for measuring any line which is already drawn, or for drawing lines of a particular length. You can put it back. All these instruments have magnetic magnets so that they stick back and retain their position. When I move my hand towards right, the next set of components are referred to as point markers. Now you can see in this point marker, there is a sharp point. And then you have a flat area, which is referred to as fin. So point would be used to mark a point on a sheet, because any construction involves points and then lines drawn to join these points. But what we try to explain to the child is you will use this fin area or the flat area to move the pin marker on the slate, which I'll discuss later. But basically, these pin markers are for marking multiple points. And on the top surface, you have 4 such pin markers. Again, they are magnetic, they'll just retain their place. Going towards right, we have a long stick, thin long stick, which has a small circular part in between. So this is your line marker. Third component is the line marker, long line marker. Long stick, equal on both sides, and at the center you have a smaller circle which has the magnet inside it. So that's how you can recognize this easily. So this is your line marker. This will be used to draw lines. So first we draw points, then we have to draw lines. For that we would need line markers. Then next to the line marker is the second line marker, which is similar but shorter in length. So magnet is at one end of it, not at the center. So it is easily, so both of them can be easily distinguished. So the marker has the magnet on the top end, and whereas long line marker has the magnet in the center, and the length is also half, nearly half. Again, I'm putting it back. Now to draw this, these lines using the line markers, we need a tool which is similar to your stylus. So in this tool, how children can recognize, one end is flat and the other end has two teeth. Like the teeth when we were 3-4 years old, front two teeth, and there's a gap in between. So you have to make use of this gap in between to draw lines or to draw anything in this kit. At this point, it's important to teach a child how to move the stylus on the different markers. So let's try it on line marker, short line marker. So the teeth part will always go down. As you can see, this teeth part will always go towards the top of the marker. And you have to use this gap to place this gap over the line marker and then slide it to draw the line. So you will use this cavity or the gap to fit this stylus over the top edge of the line marker, and then you can just slide it, and you can easily naturally draw a line, or you can easily trace a surface basically. So for children, this step is very important at this point. They should become very comfortable in identifying the gap and then putting the stylus on the markers. So they can try out with line marker, short line marker, they can try out with long line markers. Same step has to be repeated. Holding, you can see at the end where you have the teeth, exactly opposite to that, you have some textured lines. So this is where you can place your index finger to put the pressure. Thumb will go sideways, other three fingers will remain rolled. Index finger, you can see the position of the index finger. This is how it's easier to use the line marker. And then once you have this, you can put ample pressure and you can decide whether you want to keep it low or high just by moving your, pressing your index finger down. Okay. Next to stylus, we have another instrument, which is technically the protractor. So instead of a D, it's full 360-degree thing can be done on this using this device. Again, this protractor has tactile markings. We'll come to this in detail later on. It has tactile markings, which is referred to as angles, 10 degrees, 20 degrees, and so on, up to 360 degrees in the intervals of 10 degrees. You have the lines, and then in between you have the dots. So you can measure up to a resolution, or you can draw up to a resolution of 5 degrees using this protractor. For children, it's easier to identify this as a lollipop with a hand, with this place to hold it. So our big lollipop is here, which is our protractor. Then below that, we have the set square, which is a right angle triangle kind of object. And commonly you will children would be using this if they want to quickly draw an angle of 90 degree or 60 degree or 30 degree. So by differently placing the set square, it can be used to quickly draw these three angles, or otherwise just like sighted people, when we could not find the scale or anything, we would use the set square. Uh, it's not that commonly used, but I would say for drawing this 30, 60, and 90, which are the most common angles in most of the constructions, children can make use of this and save a lot of time. So at one, if I say this set square has vertices A, B, and C. So at vertex A, if I use vertex A, then the angle is 30. If I use vertex B, then the angle is 90. And if I use vertex C, then the angle is 60. So this is the first layer where we have the basic tools for doing various constructions. Moving up. So once we are done with this, we ask the child to lift this foam arrangement, the top layer, lift it up and just place it on the other side of the box like this. Then you will come to the layer 2. Layer 2 is the main thing on which all the drawings would be done. Again, this is a magnetic slate board. You can say it's a magnetic slate. And during the constructions, we recommend that students should keep it in a portrait style or just like the braille slate, exactly similar to the braille slate. On the top, you have the mechanism for locking the sheet. You can lift it up and place the sheets, place the braille paper here. Then the grooves are given on the left and the top, right side of the in this locking arrangement. The sheet would get locked once you flip it back. So once you flip it back, put a little bit pressure on this locking mechanism to lock the sheet here. We'll do it step by step. For now, just this is just an overview. Once the sheet is locked, I can use any point marker or line marker, and then because this is completely magnetic sheet, so slate, so I can move the components and they will stick to the place wherever I leave this. So it becomes easier for a child with visual impairment to keep the various instruments intact on this sheet during the construction. So for this, at this point, the main thing is locking mechanism. Number 2, the orientation, which is portrait. That means the locking mechanism would always be up away from my body. And then there are grooves or the cuts given on the left and the right edge of the slate. You can see on the left and the right edge, you have grooves at equal intervals. Basically, these are given to orient the instruments horizontally on the sheet, because I want to keep the line straight. So I can make use of these cut marks. Wherever I'm placing, I can make use of these cut marks to basically ensure that my line marker or anything else is in a straight line, straight horizontal line. So it's basically to help the children to check the orientation at any point, and they can use them as reference points. So point number 3 on the left and the right, and then I can check how suppose I want to place the scale. So the length of the scale is exactly equal to the length of the slate. So I can orient my scale horizontally by making use of these cut marks like this. So I have aligned it horizontally with the third cut mark on left and right, and then similarly I can move it up. When I am moving it up, again I'm ensuring that I'm moving equally from both the sides, and again it is horizontal or in the sleeping position. So by making use of these grooves, you can easily do this. Okay, now let's go to the third layer. Third layer has two things: circle markers and circle frames. These fan-like structures are referred to as frames, circle frames. So there are two circle frames and two set of circle markers on the left and the right side. It's important to understand why these are given to us. As a sighted person, if during constructions, if we have to draw a circle of any particular radius, then what we will do, we'll take out a compass, open the compass such that it is the distance between the two needles of the compass is equal to the radius of the circle. But for the simplicity, what we have given here is we have given the rings of various diameters so that a child with visual impairment can just draw the circle by picking up the right ring. Now on a sheet, normally, or in all mathematics constructions, normally you have to draw circles of up to 85 centimeters, 80 centimeters. So you have rings on the left side, you have rings of 30 millimeter dia, not radius, 30 millimeter dia, 40 millimeter dia, 50 millimeter dia, 60, 70, and 80. So on the left side, you have rings of 30, 40, 50, 60, 70, 80. And on the right side, you have rings of 35, 45, 55, 65, and 75. So multiples of 5 are on the right side, and multiples like in general 10, 20, even, or you can say even odd. So even is on the left and odd dia are on the right side. How will we use them? So basically we have to, whenever we want to draw, we'll place the circle marker on the slate. Now circle marker has the 3 fins or 3 wings. We call this as fan also. You take out a fan. For a child, it's easy to recognize. You take out a fan. Now place the fan such that one wing is vertical or is in the standing position with respect to the slate. And now take out a ring of a particular diameter. Suppose I have taken out a 70 millimeter dia ring. Now locate the position where you have braille on both sides with a small gap in between. So braille, when I say braille, basically it is written, this is 60 mm, 50 mm, 40 mm, whatever it is. So you have 2 braille markings, and in between you have a space. So if you go reverse, then there is a depression. You have to make use of this depression area or this groove. You have to make use of this groove to place the ring on the ring marker, such that once you place it, left you have braille, center you have braille, and right side you have the same braille. So that's how you can place. And once you have placed on one side, the other 2 sides will get aligned automatically. Just a second, let me check. Okay, so I have picked the wrong frame. Let me pick. So once you place from one side, the other 2 sides will get aligned automatically. So that's how you can place the circle markers or the rings or the chudiyan on the circle marker or the fan. Similarly, if you want to place another dia ring, then you pick it up, locate the braille where it is close to each other, then locate the groove on the back, then just put it in the opposite groove on the circle marker. Put it from one side, the other two sides will align automatically. This is something that students can try out so that this becomes easier and they are comfortable with this. So during the practical session, we spend significant time in making students try this out on their own, make it like a game for them for the first time. And when they do this thing with different with different rings, so we ask them to put all the rings on the slate one by one in the concentric circles form, and then put them back in the same place. Try it out with the circles on the right side, and then repeat. Keep on trying it out unless they become very comfortable with this thing. So I'm taking the circles out, putting them back. And then you place the circle markers back. Now, how to identify these two separate circle markers? So there are simple clues given. Like if you look at the circle marker on the left side. So one circle marker is fixed on in the box itself, so that you can always place these rings properly in this circle marker, and the other circle marker is something which you can pick and place on the slate, sorry. So on this circle marker, which is on the left side, on the back side, you can see there is no texture given. No texture is given. But if you lift the circle marker on the right side, you can see a texture is given. So making it easier on both sides. So on the wings on the back, you can see there is a texture, and on the front in the center circle, there is a texture. So this is how a child can easily distinguish between the two circle markers without counting. See, by reading Braille, or anyways, child would know the left circle marker is one which has 30 and the right circle marker is one which has 35 as the first Braille reading. And the Braille reading is also there on all the wings. So it's not, orientation doesn't matter. You can pick and use the way you want. And even if you don't know the Braille, then also it's easier to just learn the basics. If you know numbers 1, 2, 3, 4, 5, then you are good to use this kit. Okay. So this is our circle marker thing. So this is clear. Now we ask the child to lift this third layer also. And on the fourth layer, what you get is the not the circles, but the cut part of the circles, which is arcs. So these are exactly similar to your circle markers and circle frames. So here you have arc markers and arc frames. And again, one is like 80, 90, 100, sorry, 9. They start up to 80, we have circles. Then from 85, we have arcs. So 85 mm, 95 mm, 105 and 115. And on the right side, you have 90, 100, 110, 120. So that's how the arcs are there. So arcs are generally used in higher classes where we want to, like, you want to draw a perpendicular bisector and you want to create an arc, so something like that. At that time, you would use this, but for the beginners or the lower classes, you don't need these arcs. You have to use them in exactly same manner as the circle markers. In addition to the arcs, we have given additional point markers. So if student lose or misplace some of the point markers, they can make use of these two additional point markers. Or even if their stylus breaks, there is a backup stylus given here. So this is all about the kit, the components of the kit. When you would be introducing this kit to the students, you can actually decide in how much detail you want to go. Suppose you are explaining this to a class 4 or class 5 or class 6 student, then you can just introduce the level 1 instruments, and for the circles you can just make them understand how to draw a circle. Just 1 or 2 circles, it's good enough. If you're introducing this kit to the higher standards, then first they should become comfortable with the basics, and then the detailed constructions can be taken up where more components would be involved. So basically it's like a staged approach, or the incremental learning will happen just like we do in any other subject. Up till now, any points, anything you want to ask, please ask, and then we'll move ahead.
Okay.
Any questions, sir? Any? Ram sir, anybody wants to ask any question?
Yes, David.
Sir, just mute the speaker and ask the question. I think it's echo.
Sir, on the scale, how can we identify 0, 1, 2, etc.?
Okay, wonderful. So on the scale, you have tactile markings. Let's first understand the meaning of tactile markings here. So if I start from the left side, then I have a long tactile vertical line, or the embossed vertical line, followed by 2 dots above it. So left long line, then 2 dots. Then I have a small line with no dot. Then I have a long line with a dot. Then I have a small line with no dot. And then I have a long line with dot, and so on. Right. So basically what is happening, when I'm starting from the left edge, there are 2 dots and a long line. This is my say 0. Okay. Then I have a short line with no dot. This is 0.5 or the 5 mm. Then I have a long line and a dot. This is 1 centimeter. So if I want to quickly jump between centimeters, then I can just follow the lines which have dots above them. So 1, 2, 3, 4, 5. That way I can quickly count. Okay. And if I want to go to higher resolution, then I can make use of these smaller vertical lines, which is giving me a resolution of up to 0.5 centimeter. Then if I want to measure, say I want to measure something which is very long, say 17 centimeter, then I don't have to count from left completely. What we have done is to simplify the understanding. We have given 2 dots after 5 centimeters. Long line and 2 dots after every 5 centimeters. So if I have to count 17, then 0, 5, 10, just I'll go move from 1 dot. I will just try to locate these 2 dots and then keep counting. So if I'm moving my hand from left to right, 2 dots first, and then 1 dot, 1 dot, 1 dot, 1 dot, and then again 2 dots. So that means I have reached 5 centimeters. Then again, I'm moving my hand towards right side, 1 dot, 1 dot, 1 dot, 1 dot, and then finally 2 dots. That means I have come to 10 centimeters. Similarly, again, keep moving forward, 1 dot, 1 dot, 1 dot, 1 dot, 4 dots, and then double dot again, 15, see that. So it becomes faster. So then I just count 2 more dots. I'm at 17 centimeters. So basically the idea is you can use any point as the starting point and then make use of these tactile markings to count accordingly. So we'll try this out and we'll do various lengths. This will become more clear then. But for now, this concept, small line with no dots is 0.5 centimeter markings. Long line with single dot is for 1 centimeter markings. Long line with double dots is for 5 centimeter markings. Okay. Any other question?
Yes, sir, understood. And how can we find out the degrees?
So when I'm holding the lollipop such that the stick is down and the lollipop is above, this is how you hold the protractor. But when you want to use it for doing any measurements, you'll always keep this
Sir, please
marker.
excuse me.
Huh.
Like when we see the scale, one side is flat and the other side is cut. What is the significance of this?
For this cut marks, I'll just give me a few minutes. When I'm doing the actual demo, I'll explain the purpose.
Okay.
Basically, the cut marks are used for aligning the objects. Like if I want to place a point marker, I will put a line such that the point of the point marker is sitting in this area like this. So your point marker would just go, it is basically used for aligning. So these teeth can be used to lock these the point markers. Not lock, this is not the right terminology. I would say to place the, if I want to measure distance between 2 points, then I'll put the line markers such that they sit inside these teeth, in the gap between these teeth, or inside the grooves like this. We'll come to this in exact practical thing. We'll come back to this.
Got it. In the practical side, we can understand that.
For now, I'm just giving you the overview of these markings. How to use it, I'll explain later. But for now, if you're holding this protractor such that the longer stick is vertical facing down, then you can use this as a 0 reference. That is 0 degrees. Next dot is 5 degrees. Next line is 10 degrees. Next dot is 15 degrees. Next line is 20 degrees. Dot is again, so 25 degrees. And then line and a dot, that is 30 degrees. Just like on scale, we have 5 centimeters so that we can easily move. Here we have used dots, small dots for 5 degrees, lines for 10 degrees, and line and a dot for 30 degrees. So if I have to move from 30 to 60 to 90, I can just quickly locate line and a dot, line and a dot, line and a dot. So I can use this for moving to 30 degrees. And I can also use the spokes of this circular thing. I can use the spokes. So each spoke is like 30-degree interval. So I can count the spokes. So if I have to draw 270 degrees, so then I have to 30, 60, 90, 120, 150, 180, 210, 240, and 270. Directly come to 270. So it becomes easier. Basically, all these things are given so that it's easier for the child. And similarly, if you look at the periphery of the protractor, again, the tactile markings are given, like if you have a wheel, so the tire part. On this, you have again lines which are exactly aligned with the 10 degrees. So you can make use of these also during the constructions. Okay. So shall we move to the actual
Okay.
constructions?
Yeah, we can move. We can move to the next. Yeah, actual practices.
Okay.
Into actual practices.
So now we'll do the construction. For doing the construction, the braille paper is also given. The lid of the box is there. On the back side of the lid of the box, you have a folder, plastic folder, which is open from the right side. So you can make use of this to just slide out the braille paper. So when you take the braille paper out, let's first learn to lock the braille paper. So we'll place the slate in the portrait position. We'll lift the locking mechanism. Pick the paper, try to fit it on the upper edge of the locking mechanism. Once you are familiar, okay, you are at the right position, then flip the locking mechanism so that sheet gets locked. When you will just flip it, you will hear a sound, but this way locking is not complete. See, I'm using my left hand to keep the paper in the correct position, and I'm using my right hand to lock the sheet. Once this is flipped, then you press it once more, these two grooves, so that the sheet is properly locked. So once you press it, you will hear a sound just like you hear when you prick the paper on the braille slate using the stylus. Exactly same way, you will hear some sound. So that ensures that your sheet is properly locked on this slate. Then you must teach a child how to flip the sheet. So before doing any construction, we have to place the instruments on the slate. So for that, my paper should not interfere, but I have locked the paper. Then you fold the paper softly on and lift it to put it just below the slate on the back. Like this. So when you will explain this, children will start doing, they'll bend the paper, and they'll put so much pressure that it will come out from the sheet like this. Okay. So that's something you have to explain. Folding the paper is also a, so again lock it. I'm again locking it. And then I'm just softly folding it back and putting the other end of the paper just below the slate. I've created like a cylinder using the paper. So now I'm ready for my constructions. Everything starts with a point. So we first must learn how to place the point marker. So suppose I want to create a point here aligned with the third groove on the slate. So I'm using my index finger to touch the groove and then just moving the point marker a little bit away from the left groove towards the right side. Okay. So my first point marker is placed here. Similarly, okay, and now how to mark a point? That's the first step. unfold the sheet, identify the, softly move your index finger or the finger, whatever you are using, you use regularly, to locate the point, sharp point of the point marker. Don't press the sheet from there. Try to press the sheet little bit away from the point so that you don't hurt yourself. When you press it, the point will come out, and this is how you can mark a point on a sheet. That's step number 1. Similarly, you can use another point marker to mark another point on the sheet. Again, you can, if I'm concerned about aligning them horizontally, I can see from the right side, right side groove, third groove, how is my point aligned. So now it is aligned properly. So left point I have already marked. Again, I'm locating where the sharp thing is on the next point, and don't press it above that sharp point. Press it little from the side, and the sheet will tear. This way you have marked 2 points on the sheet. Once you have marked the points on the sheet, next is, suppose we want to draw a line. So again, fold the sheet softly. No movement of the points. Don't move the points. Take out the long line marker, and on the back side where the magnet is there, you can see there is a cavity given, like a tunnel kind of thing is given. So make use of this cavity. Again, turn down the line marker and make points. It's like placing the line marker over the point marker, such that the points are sitting inside the cavity like this. So make use of this cavity area on the back side of the line marker, such that points just sit over this. Sorry, line marker sits over the points. And you are ready to draw your first line. Okay. Now, again, bring back the sheet. Go to the first point. Point is already there. Go to the second point. So try to locate the points with your fingers, and just use your hand to create a rough impression from the point A, left point, to the right point, like this. So the tactile line is already there, but this is not a proper line. This is like, before I draw, I just created some impressions so that I'm aware about how long the line is and I have exact understanding. Now take out the stylus with teeth facing downwards. Try to place the gap between the teeth on the line marker from the point A on the left side. And then just press it gently and slide it over the line marker. Press the stylus gently and slide it over the line marker only up to point B. So when you are sliding, in between there are no points, but once you reach the point B, there will be slight obstruction. So you can identify you have reached the end point B and your tactile line is ready. Now lift the paper again and remove all the components from the back and place the paper back again. You can see a distinct tactile line, which is representing your first line drawn using these instruments.
Clear? It's very clear, and everybody did a practical also. Very easy.
Now let's say we want to draw. So at this point, once we give this exercise, we ask the child to draw multiple lines in different orientations. So we ask them now draw a vertical line, now draw a slant line, and so on. So they become very comfortable with points and lines. So they can try out various lines. Now let's see how to measure the line. So suppose you have a already drawn line is there, and you want to measure the length of this line, right? So you will place the scale over the paper. For now, I'm putting it above the paper, not below the paper, because I just want to measure the line that I have just drawn, how long it is. Okay. At this point, for measurements, you will always make use of the flat side. You will not use the teeth side, you'll use the flat side. Because when you are moving your scale as a blind person, suppose I want to go to the line I want to measure. So I locate point A. With my, say, left hand, I'm using the index finger to locate point A on the left. Okay. I have located the point A. So I know from where I want to measure the length, but where is this line horizontally? So when I place the scale and push it gently upwards with the flat side down, it will just go hit the line and the scale will get blocked automatically because of this embossed line just above it. Okay. So it becomes easier for you to align the scale with the line if you use the flat side. Okay. So point A on the left, you know where it is. Try to align the leftmost point of the scale with point A. Okay. And then you look at where is point B coming on the line, and then just try to read the reading of the scale above it. Okay. So now I know, and then I can. So what I'm doing now, I have located point B, then I have located the reading corresponding to point B on the scale. I have placed my finger there. Now I'm using my left hand index finger to just count how far is this. So leftmost point is 0. Then I'm just going to 5, next 2 dots. Then I'm going to 10, next 2 dots, 10, and then 11, then 12. Now after 12, my right hand finger is coming. That means 12 is there, and then in between reading is there. So this is 12.5 centimeter line. So that's how you have to make use of the scale for doing for reading or for doing measurements. This is how we have to use the scale if we want to measure any drawn tactile line or anything on any diagram. For example, if I have a tactile book, just give me a moment. So suppose now I'm opening one math book which has tactile diagrams already in it. In that, there is a first page, there is a rectangle. Okay. So you want your child to measure the length and the breadth of the rectangle. So you will ask them to align the scale such that the left corner of the rectangle is aligned with the leftmost marking on the scale. And then I'm using the flat side, so it will just get blocked against the baseline of the rectangle. And then I'm just trying to locate the right base corner of the rectangle and reading the corresponding value on the scale. Placing my finger, right hand finger on the end reading, and then I'm just moving my left finger to count. So 0, 1, 2, 3, 4, 5. Okay. This is 5. And then next, my finger is on 6. So this is 6 centimeter baseline. So this way, you can create your own exercises depending on what subject, what concept you are teaching, and make use of these instruments for doing measurements on existing tactile diagrams. So this is how you can, like, this is an angle. So I want my child to measure the baseline. So I can measure the lines like this. So this is part 1, how to use the scale to measure any existing length on a tactile diagram. Now let's use scale to create a line of desired length. It's like more like a constructions exercise. So suppose this time you have to draw a vertical line of 5 centimeters starting from point A itself. So you have point A. Point A, we are saying, is the point which is on the left side that we have just drawn for the horizontal line. Now I want to draw a vertical line, basically it will become a 90-degree angle. So you place your line marker back. When you place your line marker back, focus is yes. Okay. So when you are using the line marker, so I'm moving the line marker back to the point A. So I'll just try to align the hole which is already created on the sheet for point A with the actual point of the point marker. Even if you keep your eyes closed, then it's possible to locate and place it back to the same position. So my point marker is on point A again. I have placed it back in the same hole. It is aligned. Now I want to place another point marker. So suppose this time you want to draw a vertical line of length 5 centimeters. So this time you would be using the teeth side of the scale. So move your teeth side of the scale and try to see how I am adjusting the fin. I'm adjusting the fin such that it is opposite to the teeth. And this time I'm not using the leftmost marking as the 0 point. I'm using this 5. 0, 1, 2, 3, 4, 5. This 5 as my base. Value 5 centimeter as the starting point. Okay. And then I want to draw, say, 10 centimeter line from this. So I'll count up. So if I'm using this 5 as starting point, so 5 would become 0 then. 5, 6, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So once you are at 10, again, try to slide the point in the teeth corresponding to value 10 centimeter. Try to slide the point marker in the teeth corresponding to 10 centimeter length. Okay. So now you have placed 2 point markers 10 centimeter away from each other and they are vertical. Child can make use of some reference to ensure that the scale is in vertical position. Once you have done this, you can remove the scale just by sliding it away towards right. so that point markers are not disturbed. Take it out from the slate. Unroll the paper. Mark the points. Points are marked. And then what you have to do is to place the line marker over the point markers, just like we did earlier. Now we know where are the points. So we'll just draw the rough impression first with the hand. Using the thumb and the index finger, we'll try to create the impression between the points, and then finally locate point B, put the stylus there, the teeth gap in the stylus, and then slide it down up to point A. And your vertical line from the same point is ready. So that's how we can create line segments of any length of desired length by making use of scale. Anything you want to ask till this point?
No doubts are clear.
Okay. Now suppose you want to measure the angle. What is the angle between these two lines? So you can make use of protractor on this sheet itself. How will you measure any existing thing? Place your protractor. First hold the protractor from the center of the wheel. Like in your lollipop, locate the center. Put your finger inside it. Hold it using your finger. Now try to place the protractor such that the point from where you want to measure the angle is exactly at the center of this small circle. So it touches your finger like this when you place it. So the hole or the point is exactly in the center of this small hole on the protractor. So this way we can place it. Now try to align the stick part of the protector, the marker part of the protector with the point B such that it is over the point B. So then this is my reference now. So first I want to create the reference line. Okay. Now then I start counting upwards. Once this alignment is done, that means my reference line is set. Then this reference line is baseline 0 degrees, 10. So I can count from outside. 10, 20, 30, 40, 50, 60, 70, 80, 90. Once I come to 90, my finger touches the tactile line on the base also. So now I know the groove is there, this marking is there, the line is also there. So it is exactly aligned with 90. That means I have drawn the lines which are at an angle of 90 degrees with each other or are perpendicular to each other. So this way you can measure any angle. So use the outside grooves, just like in scale we have used in a certain way. Similarly, will on the protractor, if we are trying to measure the angle which has already been created in the tactile diagram, use the outside grooves. So this way I know this is 90 degrees. Now let's try it out on some of the other diagrams which are part of the existing book. Some book is there. See, here we have tried explaining the different angles. Right? So this is the diagram. Now let's say I want to measure this angle. So again, I'll put my finger in the hole, hold the protractor like this, and try to place this protractor on the point from where I want to measure the angle. I've placed it properly. Then I have to see my tactile diagram. The baseline should be aligned with the baseline of the protractor. Now this baseline is set. And then I can start counting up and try to locate where it is. So in this particular diagram, it's not working properly because the length of the angle is too short, that it is not coming out from the other end. But fine, we can do like some approximation by using the tactile line from the gap here and try to see what it is corresponding to. So this is one way, or let me try on something. Suppose I want to measure this angle. This would be simpler, of the triangle, angle C. So I'll put the protractor on point C, this point, align it with the baseline, and then start counting up. So 10, 20, and this is line is coming between 10 and 20. So this is 25. So this angle is 25 degrees. This angle is 25 degrees. That's how you can use your instrument for doing measurements of pre-existing diagrams. Now we'll do the reverse. Now I want to use the protractor to draw angle of 45 degree in this diagram itself. So I have a diagram where I have drawn right angle. Now within this, I want to draw angle of 45 degrees. How can I do that? Again, I'll use the point marker and Sorry, I'm back. My internet plan expired. So initially I could not understand what happened. So sorry for that. Okay. Kumresan, give me screen sharing rights.
Can we have 5 minutes tea break?
Sure, sir, sure.
Okay.